Hi there, in this video I'm going to go through the integrals of hyperbolic functions. So here goes. So hyperbolic functions, and this is integration. So we'll go through the integrals of hyperbolic functions. Let's take a red pen quickly, underline that. So number one, whenever you integrate hyperbolic sine x with respect to x, you're going to have hyperbolic cos x plus c, an integration constant. Number two, whenever you integrate hyperbolic cos x with respect to x, you should get hyperbolic sine x plus a constant c. Number three, whenever you integrate hyperbolic tan x with respect to x, you're going to have ln of the modulus of hyperbolic cos x plus c. Result number four, whenever you integrate hyperbolic cot x with respect to x, you'll have ln of the modulus of hyperbolic sine x plus a constant c. Okay. Number five, whenever you integrate hyperbolic sec squared x with respect to x, you'll have hyperbolic tan x plus c. Result number six, whenever you integrate hyperbolic sec x, hyperbolic tan x with respect to x, you need to be careful, it's minus hyperbolic sec x plus c. Result number seven, whenever you integrate hyperbolic cosec squared x with respect to x, you're going to get minus hyperbolic cot x plus c. And finally, this is the last of the standard results, number eight, whenever you integrate hyperbolic cosec x, hyperbolic cot x with respect to x, you'll get minus hyperbolic cot x plus c. Okay, so I've given you 8 standard results for the integrals of hyperbolic functions. Yeah, I'm going to go through some additional hyperbolic function integrals, and these integrals are based on the standard integrals that we've seen in the previous videos. Okay, so let me continue on the reverse. So this result, so I'll call this result number one. This result is based on this standard result for the integral of hyperbolic sine x. So whenever you integrate k, so k is a constant, hyperbolic sine ax plus b. So k, a and b are all constants. You should have k divided by the number in front of x, which is a, okay, hyperbolic cos ax plus b plus a constant of integration. Okay, so remember, k, a and b are all constants. So where k, a and b are constants. So you can only apply this result if k, a and b are all constants, and remember the term here is a linear, so it's of the form ax plus b. Okay, so you might say, where does this result come from? This result comes from, you can derive it using substitution. Okay, so you can derive it using substitution, taking u to be ax plus b. So if you take u to be ax plus b, using substitution you can derive this result. Okay, so let me show you. If I start with this left hand side, so if u is ax plus b, du over dx, whoops, when I differentiate, that will be a, and du is a dx. Okay, but in this case if I rearrange for dx, dx will be 1 over a du. Okay, so using substitution we can replace the dx here by 1 over a du and replace the entire ax plus b by u. So by substitution, okay, so I hope you can see that. So integration sign dx, I'm going to replace by 1 over a du, so this dx here, so I'll write the 1 over a, and I'm also going to write that k outside as well. K is a constant, so you can only bring constants out of the integral, so I'm going to bring out that k as well as the divide by a outside, and du of course we write inside our integral, and also hyperbolic sign ax plus b replaced by u. Okay, and remember, whenever you integrate hyperbolic sign, that's the standard result, you're going to get hyperbolic cos, so it's hyperbolic cos u plus a c. And since u is equal to ax plus b, okay, so that is our substitution, so that comes from the substitution here. If I replace the u here by ax plus b, we'll have k over a hyperbolic cos u, which is ax plus b, plus c. So that is how that result here comes about using substitution. Okay, so I'm not going to prove the remaining results using substitution, I'm just going to quote them. Okay, but in order to prove them, remember, these are the steps. So you need to use substitution and take u to be ax plus b, so the term over here, go through the method of substitution in order to get those results. Okay, so let me give you the results of the others, so just some of them, so I won't go through all, but you'll see the idea. Whenever you integrate k hyperbolic cos ax plus b with respect to x, so here's the idea, it's going to be k is a constant. Standard result, whenever you integrate hyperbolic cos, you get hyperbolic sine, so it's a hyperbolic sine ax plus b divided by the term in front of x, which is a, okay, so or the coefficient of x, which is a, and then add c. Okay, so don't learn the formula, just learn how this result comes about. Okay, so result number three, whenever you integrate k hyperbolic tan ax plus b with respect to x, so k is a constant, so it's k over coefficient of x, which is a. Whenever you integrate ln, that is an ln, so rather whenever you integrate hyperbolic tan, that's an ln modulus hyperbolic cos ax plus b, okay, and add a c. Okay, so just one more, result number four, say whenever you integrate k hyperbolic cot ax plus b with respect to x, k is a constant, keep the k outside, coefficient of x is a, integration of hyperbolic cots, that's a standard result, that is ln modulus hyperbolic sine ax plus b, add c. Okay, so I won't go through the remaining results, but if you know the pattern, so if you understand how these results arise, then that's better than memorizing a formula. Okay, and of course, if you do a lot of examples, by doing plenty of examples, you'll be slowly memorizing these results as well. Okay, so that completes this video. In the next video, I'll be going through some examples of how these results are applied. Okay, so I hope to see you in the next video. Thank you.